Welcome in to our webinar on industrial AI in action. I'm here with our friends over at Crosser, and we're going to take you through an end-to-end workflow for event-driven machine vision. I'm joined on the Databricks side by Zach Jacobson, who will be monitoring the chat. So if you have questions as we go through the presentation, feel free to put them in the chat, and Zach will get to them. We will have an open Q&A at the end of the session here today. But I'm your host, David Rogers. I'll be leading you through. I lead our industrial industry solutions here at Databricks, and I'm joined by Göran Appelquist. Göran, you want to introduce yourself?
Yeah, sure. So I'm the CTO at Crosser, based out of Stockholm, Sweden. I will take care of the Crosser parts of this journey today.
Excellent. So with that, let's get into it. Some of the kind of key challenges, kind of starting off. Why is this something that people are struggling to deploy machine vision at scale? The first part we're going to kind of cover today is all around training and deployment. This MLOps, this life cycle of managing machine learning models that can be deployed in an industrial environment securely, can do it at with restricted environments, monitor how the model is performing so that you get the resiliency and the deterministic nature that you expect when you're doing quality applications or process monitoring of your manufacturing process. So all of these things, as you kind of go into the machine learning and AI world, being able to understand how the model's performing so that you know that the product you're producing in your manufacturing process is of good quality and you have no defects and no escapes, or if you do have some, you can trace through and figure out what the root cause is because you're able to detect them through techniques like machine vision. So that's one of the kind of key things I'll highlight here on the Databricks side. Jorn, you want to talk through the edge side and the edge orchestration problems that you're seeing over that you solve with Crosser?
Yeah, so there are a couple of things you need to take care of. I mean, first thing is to get the actual model into a distributed environment, which could be protected by firewalls and other things. And that's the first challenge. Then we need to get access to data. I mean, we need data from real devices, so we need access to that data. And then eventually we'll want to use the result of that model to take some actions, as David exemplified. You may want to just remove parts that are detected as faulty, or depending on the type of use cases, you might want to stop a machine to prevent further damage and so forth. So different actions, or maybe just inform someone, show a picture locally to an operator so that they can make a decision and so forth. So there's a lot of interactivity with the local environment required for this, in addition to preparing the data. I mean, it's not just enough to connect into these local environments. You need typically to do some kind of preparation of the data before it can be used in a model like this. Now with vision, it might be a bit more straightforward, but with other use cases, you may need more preparation of data before it can be used in a proper way with these type of models. So that's what we're going to talk about today.
Excellent. And the way we're going to bring it to life for you all, so we're going to certainly talk about the Databricks and Crosser technologies. We're also using a model type called YOLO. You only look once. That has gained prominence in industrial machine vision for a variety of reasons. One is that it's very computationally efficient to run the inference. So that's going to be critical. So you can kind of see that on the chart. That's a little covered there. And then we're also going to have the model in ONNX, Open Neural Network Exchange format, so that it can be interoperable with no matter what kind of hardware or edge compute you have. You're able to run it and it's able to access that hardware and be interoperable wherever you need to deploy it. So in heterogeneous hardware environments, you're able to have one model that you're able to deploy anywhere across your factory network. So those are some of the core elements we're going to bring to life in this demo. But to start here, we're going to kind of take you through the end-to-end kind of capabilities within the two platforms and how you drive this entire life cycle from training the models to controlling where they get deployed, monitoring them, and then executing at the edge, and then feeding data back into the cloud to retrain, update, and do the end-to-end model lifecycle. So we'll take you through this step by step here today before we get into the demo and actually show you end to end. So first off, we're going to kind of talk through Databricks, what's going on in Databricks land, why do you need the cloud layer and Databricks specifically to address this problem? Well, first off, you need MLOps, and this MLOps for those maybe coming from an OT background or a manufacturing engineering background, it's really the set of processes that enables you to create and manage the machine learning model that you're deploying within the manufacturing environment. So you want to be able to govern it. It takes some code that your IT team understands and can build. It takes data, as Göran mentioned, the data is so critical to training these machine learning models, and then actually building the model itself, managing the model, understanding how it's performing. All of those capabilities are things that you need to be able to have a handle on. And then you also need to be able to govern this through its life cycle. So you need to know what the state of that model is, who can use it, what factory, what production processes is it deployed in, understanding the context in which it's deployed, so that you're not just putting a model out into production and then nobody knows how to actually improve it or take it out of production if it's not performing correctly, and swapping in maybe a backup or a B version that can maybe do some other detections that are maybe less sophisticated but more reliable. And so you're able to think through those trade-offs, and the way you orchestrate that is through this MLOps process. So on the Databricks platform, we bring this to life, kind of these data ops, model ops, DevOps, through kind of three sets of tooling. Data ops, you have Delta Lake as a file format that allows you to scale very efficiently in the cloud and manage and have transactional data of all your images in machine vision land, but it can be tables. It can be other data artifacts that you want to transactionally be able to understand their history, where they came from, what process they came from, and manage that through its life cycle. We have ML Flow, which is an open source. Delta Lake is also open source way of managing artifacts within the machine learning training and management. And then DevOps, actually managing the code that's building the machine learning model. So we bring this to life in Databricks through workflows, our cloud serving, or in this case, export, so that Crosshair and technologies can pick it up and bring it to the edge, and then Lakehouse monitoring to monitor the models and code through its life cycle. And then all of this is governed through our governance framework called Unity Catalog. So I'm going to actually skip through this one. There's things around you want MLOps for managing risk, but it's really about this lifecycle management. So you want to make sure that as your manufacturing process, right, it's not static. It's changing. You're updating it. You may be retooling it. You may be rerouting things. You may be upgrading equipment, changing out equipment, or equipment failed and you replaced it. All of these things may cause the data that's being captured in the manufacturing process to change and drift. And so you need to account for that when you're dealing with machine learning. You can't just say, hey, we're going to train this machine learning model once. Oh, yeah, it's just machine vision. We have this camera and it's always going to perform the same. The result is there's a dynamic thing that is changing in the physical world, and you need to be able to handle that to intelligently retrain the model as the manufacturing process changes with it. So then that way the model's always up to date. It's performing the way you expect to capture defects before they become escapes, and they're able to respond and figure out root cause to anything that may be causing defects faster. So that's this whole kind of concept of model and code life cycles that it can be very, very challenging to try and manage this all in the OT environment. Doing this in the cloud environment and the IT environment is going to give you the tooling you need to do it successfully. That's the key takeaway for this aspect. And then there's the governance aspect of it, of understanding access to these models, auditing how they're being used, the lineage of what data came in from which facility on which line, joined with which maybe product information about how it should look, how it's designed, comparing, actual in the manufacturing process versus as designed, and being able to discover what's available, what models can I use to actually deploy on the edge. All of these things are the things that you're able to solve for with our governance layer of Unity Catalog. And then this brings that model lifecycle with the governance to life. So there's a lot of details here that I want to make you aware of as part of this conversation. But as you go into really building out your industrial AI ecosystem on Databricks, please reach to your Databricks account team, help guide you through how to do this. Because there's different skill sets when it comes from the machine learning engineers to the process and manufacturing engineers that are dealing with the problems in real time. And so being able to understand these concepts and tailor them towards what makes sense for you all is something that our account teams can help you with, design that end-to-end life cycle for your industrial AI applications. And then last thing here before I turn over to Joran is all about the monitoring. So this is another kind of deeper discussion of understanding how this data is drifting. So how the manufacturing process, how the camera gets dirty or it starts performing poorly for whatever reason. Maybe the resolution isn't as good as you need for certain defect detections. Being able to actually understand that and quantify what that means in terms of the impact on the machine learning model. That is something that Lakehouse monitoring within Databricks will help you understand. So you can get ahead of, oh, we do need to retrain this model now and redeploy it because the data has drifted so much, or maybe we added a new product onto the manufacturing line, and now we need the machine learning model hasn't seen it before, so we need to retrain it. And Lakehouse monitoring can help you understand that. So if your OT makes changes and maybe they didn't get word all the way to the IT team, your IT is able to actually detect it through this Lakehouse monitoring before OT even tells them, the process engineers even tell them that they updated it. You can see these type of things in real time through the data itself, rather than waiting for a reaction to, oh, it's not, it's no longer working, what's happening? You're able to see it through the data and intelligently retrain and deploy back to the edge without even the manufacturing personnel maybe even noticing. So with that, I'll turn over to Jorn to kind of take through how Crosser can take the models that are trained in Databricks and bring them into the edge. So Jorn, just tell me when you want to move on to the next slide here.
Yeah, thanks, David. Yes, so starting with a quick intro to Crosser, so we get some context here. So Crosser is a platform for designing and deploying use cases to run wherever. It's designed specifically for hybrid deployments. So that's why it's a very nice fit with these type of use cases. And we've done that by separating the design and management layer, which we call the control center, from the actual execution environment, which we call the Crosser nodes. So that you can design a use case centrally in a cloud service, and then from when you have built something that you're happy with, you then decide where you want that to execute. And that can then be anywhere where you decide, depending on where you deploy these nodes. And if you go to the next slide. So if we start with designing use cases, you do that in the control center, and we have adopted a low-code approach to make it as easy as possible to build these kind of use cases. So we provide a library of pre-built modules that you can combine together into processing flows like the one you see on this slide for a specific use case. When it comes to machine learning models and specifically these vision type models, we typically use some Python code to wrap them or adapt them for this local environment, but you always have full access to a standard Python environment from within these flows. You can combine fixed function modules that we provide with some dedicated Python code that you need for a specific use case, like we will see in the demo shortly. But this is where you start. Then you can also test these use cases from this central tool. And when you're happy with what it's doing, you then decide where you want to execute this use case, or this flow, as we call it. Yeah, so we can go to the next slide. So for execution, we use this environment we call the Crosser node, which is it's a single Docker container that you can install anywhere on your infrastructure where it makes sense. Could be next to a machine, it could be in your local data center, or even in your cloud environment, if that makes sense for some use cases. But the key thing here is that it's a very lightweight container. The whole thing is around 300 megabytes in size, meaning that you can run it also on very small devices sitting very close to where you have your data. And also, the whole idea with these runtimes is that they are generic. It's something that you install once, and then when it's installed, from there on, you manage everything from the cloud service. So each of these nodes can execute any use case that you build in the cloud service without having to touch these local environments. So once installed, you don't need to touch these to install a new use case or update an existing use case. You can run multiple use cases on each of these nodes. And when you do that, they run independent of each other. So you can update one without affecting other use cases you have running on the same node. The actual runtime engine that we use to execute these flows is built on the .NET platform. And as you might be aware, Python is not a native language in .NET. So in order to support these kind of Python use cases, we also bundle a standard Python environment within our container. So you always have access to that when you build these flows. Also, another thing is that all these modules that or building blocks that you use when creating these use cases, they are hosted in the control center centrally. And whenever you deploy a flow, all the modules that you use in that flow will be downloaded dynamically into this local execution environment. So these nodes, they don't know anything about modules or Python or whatever. Well, yeah, Python they know some about, but still, everything that you use in your flows will be downloaded whenever you decide to deploy a flow, which means that whenever we introduce new modules in our library, they can immediately be used in new use cases on any of the nodes that you have already installed in your infrastructure without making any changes to that local infrastructure, which simplifies the lifecycle a lot with these different use cases. So that's basically the Crosser environment. And then in the demo, I will show you a small example where we take the output from the Databricks environment and bring it into an edge environment for local execution. So back to you, David.
Excellent. Thank you, Göran. Yeah, so end to end here, we're going to walk through this now in a demo, but you'll see kind of each one of these elements. And again, as if you have questions, feel free to ask them in the chat, and Zach will get to them. So with that, let's get into the demo here. So I'm going to walk over here into a the Databricks platform here. So you can see in this case, I'm showing you a notebook. I'll show you a couple ways you can do this in a lower code kind of way. But to start, I wanted to show you kind of the end-to-end pipeline, what it truly looks like, fully transparent on how you do this. Starting with industrial optical inspection data set. So this is something that you can see here. It's published way back in the kind of early days of industrial AI from the Heidelberg Collaboratory for Image Processing. Basically, there's a bunch of texture images. I'll show you what those look like here in a second. So I'm bringing this data in and I'm bringing it into Unity Catalog. So that's, again, the governance framework where you're storing data within Databricks. This is actually just sitting in a object storage bucket in the cloud. So this is going to be S3, ADLS, or Google Cloud Storage. And all this data is just with a Unity Catalog volume, think of it as a file system. So it's just governing these files, and I'm organizing in a way that makes it easy for me to train the machine learning model. So this image, what does it look like? It's basically, you can think of this as like a film or a texture on a composite or a metal, but it's just a synthetically generated image. If you look really closely here, I don't know if you can see my cursor, but there's kind of a defect in there. We'll show you what that label looks like in a second. But these are the images. So in this case, it's grayscale. You may actually have color. Sandeep, you're drawing on the screen, which is okay. But you may have color images. It's going to work just fine if you have color. It's just a different thing that you want to think about the trade-off in the inference, depending on how the velocity of your production line is. So in like film manufacturing or paper manufacturing, it may be really high velocity, and so you may want to be able to run this in a kind of grayscale manner that's going to allow you to lower the bit rate and get you to do inferences much faster. So some things to think about. Again, we can help you think through those trade-offs when you're designing machine learning models for machine vision. But for now, we're using grayscale here. Verifying these labels and writing them to Unicatalog here. I'm actually putting these, I'll show you the data here in Unicatalog here in a second. But the labels actually came in as ovals. If you've done any object detection with YOLO, you'll know that it's a bounding box. So the next thing I do here in my pipeline is actually create this as a bounding box. So I translate these into a bounding box. And so you can see here, instead of that oval, I'm now creating a bounding box over the defect so that we know exactly where it is in a nice green color here so it stands out. So that's way you want to prepare your data. If these labeling is a key part of machine vision. There's a number of different ways you can label things. We have things within Databricks and partners that can help you go through that labeling workflow. That's for another kind of discussion, but please reach your Databricks account team to help guide you through the options you have for data labeling with Databricks. You can see here, so we labeled this. We did this across the 1,000 or so pictures that are in the class 1 kind of data sets within this data set that we pulled from. And all of this data is in Unicatalog. So you can see here, if we go in data sets, we'll go into kind of my folder. We can go to the images in here. We broke them out into train and test sets. In here, here's what the images look like. So these are exactly the images that are being stored within the platform. And then we can actually go into the catalog here. And what I did was I created a Delta Lake table that describes all of the images. So there's sample data here. You can see exactly where the ID is, if it's the label is defect or not defect. Maybe you have different types of defects. Maybe you have Parker prints, you have tears, you have all different things that you may have. So you can actually label these as those different categories of defects, and YOLO will be able to tell you which category it is. In this case, I kept it really simple. Is it a defect or is it not? So 1 or 0, 0 being non-defective and 1 being defective. And then where are these actual files located on the file system so that when I go to train the model, it's able to pick up the files or pick up the images to train the machine learning model. So in here, the next thing is actually training the YOLO model. And in this case, I'm using a library from Ultralytics. If I was to do this in production, I would want to own the end-to-end IP. So I would actually train this from scratch. In this case, I kind of took we'll say the easy button approach that Ultralytics provides to help support this. And then I'm able to run a detection here. So I'm actually just doing an inference against one of the training images, but you can see it detected one defect there in 8.2 milliseconds. So if you think about your operating environment, 8.2 milliseconds may be sufficient to do that inference, but maybe your speed is so fast that you need it to be faster. And so you can quantize this model. You can make it so that it maybe trades off inference speed with precision and accuracy, all these different things that you'll want to be able to control. You can do that very easily here in the Databricks environment. So this is something you want to think about. In this case, I just exported it to ONNX. I know my camera in the industrial environment is giving me 512 by 512 images. So I'm exporting it for that image size. And then I am putting that final export directly into my Unicatalog here so that Crosser can pick it up. So in here, if we go into, where'd I put this, manufacturing, actually, let me go into the Catalog Explorer here. And we'd go to our machine vision folder. I'm just kidding. If I go into my models folder, I moved it here. Here's my ONNX model. That is the output of that notebook, that code that I just showed you. And so in here is where there's APIs into here that Crosser can hook into to access this. So this is the ONNX format. There's things on the ONNX runtime.ai website that describes how to use ONNX, how to load this in, how to format it. So it's an open standard, something you can borrow from the community on how to use and be able to understand kind of the format and how to load it in. It can be tricky. We're here to make it easy. Just want to show you the end to end, all of this code. And as I train that model, all of the artifacts are in this ML flow that I mentioned earlier. So we can take a look here at the performance of it. We can take a look at the validation. So validation batch, we can see which ones. If I click this here, we can look in. We can see that it was able to detect defects in these images. These other ones didn't have defects. Be able to understand the heuristics of this. So that's what the confusion matrix is all about. Oops. So in here you can see it actually sometimes it double detected and actually picked up background, but that's okay as long as there's the proper defect in there. You probably just don't want false positives, right? You don't want to take good product and off the line and that the model is saying is defective when it's really not. So you want to make sure you have true positives that are picked up. And so you can look at all the artifacts in here. It's all in one place. So as you go through that retraining life cycle, you want to make sure you're maintaining the efficacy and the performance of that model. So you have that confidence when you bring it back down to the manufacturing environment, it's going to perform the way you expect. So with that, I'll turn it over to Göran to walk us through the Crosser platform. Again, the model's here in a unit catalog volume. You would use a Databricks API to pick this up. If you want the MLOps lifecycle, we have a whole book on how you orchestrate this at scale. But from here, I'll turn it over to Göran to take us through the Crosser side. Göran, over to you.
Yeah, thanks, David. Let's see if I can share my screen. Okay. Okay, so I jumped straight into the design tool in our control center, and here I built a small sample application just to show how we can use this model. But before getting into here, I imported the model that David just showed, and once it's imported into this tool, I can then reference that when I'm building this use case. I referenced it here. I actually renamed it, so it's no longer best.onnx. But anyway, it's the same file that came out of David's sequence of operations in Databricks. So this is the model file. So I just add it here so that we know that this is going to be used by this use case. I also created a small Python script with some utility functions to wrap this model to make it useful in this environment. We will see how that is used in a second. So these are just additional data that is, if I can move this, going to be used by this tool. So whenever we deploy this use case into one of these nodes, the node that receives it will see that it also needs to download these two additional files into local storage because they will be needed by this use case. So once configured, we don't need to worry about that, and we can deploy it anywhere, and it will be managed automatically. So let's take a look at this example. Now we don't have a real camera here that we can use for the demo, so we're baking it a bit by just using a couple of the files, the image files that David showed you. So I've just uploaded those into local storage. So this first part here sort of simulates the data source by just picking up all the JPEG files that it finds in the folder and then sending them out one by one at the end here. So in a real use case, this would be replaced by a camera or maybe a watch folder where we pick up image files that are put there by some other device that you have. It's not really relevant. The key thing here is that as somehow at the output, we will get image files coming out. So these will be JPEG images, and that is what we use as input into the next module here in the flow, which is our Python module where the ML model is used. And I will come back to that one in a second. Let's first go through the whole sequence here. So we send these images into the model, and then out of the model comes two things. One is a score, and the YOLO model can actually detect multiple anomalies in each image. But in this case, we're just keeping the highest score that it found in the image. So that score will come out as the output, and there will also be an image file in the output, and that is a copy of the input image, but with the bounding box around the detected anomaly added onto the image. So just like the images you saw on the Databricks side, that is created locally here for each image that has anomalies. So that is what we get as output. And then we just add a threshold here to check the score. We just want to do something when the score is high enough, which indicates that we have an anomaly. So we set a limit here to check if the score is higher than 0.4, which seemed to be reasonable in this case. If it's lower than that, then we don't do anything. We just drop the data. But if it's above this threshold, then we take some actions. And then I just added some examples here. You can do lots of different things here, of course. But first, we just created a text message where we insert the name of the image and the score, and then we send that to a Teams channel to notify someone that we found an anomaly. Could maybe be useful. But we could also take an action and write data back to the machine. Maybe we want to say that this part with this ID is faulty. You should remove it from the production line so we don't spend time on that one. Or if it's depending on the use case, as I mentioned before, it could also be that you've seen that something has happened that you may want to stop the machine so you don't destroy stuff even further or whatever it might be. But the key thing is that we can communicate directly back to the machines and take actions on the machine level based on the output of these models. And then the second path here is just to use the image that we get as output. Maybe we want to show that image to a local operator so that they can take a look and make the final decision. So just to exemplify that, I dump it on our internal MQTT broker so that we could connect, for example, an HMI device that the operator can use to take a look at the pictures and see what they should do with it. But these are just examples of actions that you can take based on the result of the model. So let's take a quick look at the inside of this Python model. What do we do to run this model? First of all, I have listed some additional libraries that we need in order to do this. So we use the NumPy library for some data manipulation. We use the ONNX runtime library, which is the environment to execute the model. Remember that we got the model as an ONNX file, and that is then used into this runtime. This runtime is available in other environments as well, so you can use it in natively in the .NET environment if you want, but here I'm using it inside Python. But it's a very efficient runtime environment that fits perfectly into these kind of restricted edge environment where you may not have a full-blown server with a lot of power to run these models. We also use the OpenCV library to do some image manipulation to prepare the images before they can be sent to the model. So I just list them here, and the purpose of that is that any node that will receive this flow or where we deploy this flow will then notify this and see that it first needs to install these additional libraries into its local Python environment before it can start to execute this flow. So this is again to make these flows self-contained. So once configured, you can deploy them anywhere without having to know anything about the local environment. Any node should be able to run this flow without further configuration. So that's the setup. And then we have a small piece of Python code here where we import these libraries, we import this utility function that we created, and then we reference the model file, which is when we deploy this flow, as I said, that model file will be downloaded into local storage, and it then ends up in this location. So we just specify that, and then we have two small functions here. Initialize, which is called once when this flow starts, and we use that to enable this ONNX runtime by loading the model file into that so that we get a runtime environment that we can use to send these images to. And we store that in a global variable so that we can reuse it. And then the second function here is called whenever we get a new image at the input of this module. So then we call this function, and the input will contain the JPEG image that we read from local disk. Now there is a small detail here that may confuse you, but since, as you saw on the slides, the Python environment is running outside of .NET, which is our main execution environment, we need to translate data when we communicate between these two environments, and we use JSON serialization to do that. And in JSON, there is no binary data type. So in order to send the image, which is binary data, we have to base64 encode it before it's being sent to Python. So when we receive it here, it's actually base64 encoded. So we just strip that base64 encoding, and then we use OpenCV to decode the JPEG image into a format that we can use with the model. So these two lines are just to create the image data set that we can use as input to the model. And then we call the model with that image as input, and we get back a result. And as I said before, that result will contain two parts, a score and an image with a bounding box. Now, because of that use case further down where I created a message, we also want to know the name of the file that where this data came from. So I copy that from the input to this module and add it to the output so that we can use that in the next module. This could have been some other information like a product ID or whatever that you can use to reference back to the source of this data. And then we send this result as the output of this module. So that will then come out, if I close down all these, it will come out here. And that is what we use in the next steps in this sample flow. So this is just a simple example, but it still covers the whole chain from data source or image data sources through the machine learning model, and then taking some actions based on that data. When we have built something like this, we can also test it within this environment. Also on the wrong tab. And when we do that, we can use any of these nodes that we have in our setup so that we can actually test run it in that local environment where it's supposed to run. So these are different nodes that I have in this demo environment. So we can use one of these to test this flow. And when we test the flow, we can check the output of any of these modules. We can track the data through this flow. Now I enable debugging on this module here. And the reason for that is that I use that module to remove the image data, because otherwise we will just see a lot of base64 data, which is not really important. So I remove that so we can just take a look at the interesting part. But we could check the data in any step here to make sure that it's doing what we expect. So if I start this flow, what will happen now is that we will download what you see on the screen into that selected node, and it will then start to execute. And we just have a handful of images in this local storage, and 3 of them have anomalies, and that's what we see here. 3 outputs, 1 per image, with the name of the file, a message that we created in this module, and the score that we got from the machine learning model. So that's the final output. Now I can't really, in this tool, show you the images, but I actually brought that up. I store it on my disk here so I can show it. So this is the same type of image that you saw in the Databricks tool, but this is now coming out of the model. So we just added this bounding box and the score to the image. So these are available as well if you want to use it inside the flow. So let's say that we're happy with this. It seems to do what we expect, and we then want to use this in these local environments. So then the final step is to open up our deployment tool, where you again get a list of all your nodes. And here you can select where you want this flow to execute. And I can select the one that I used for testing. But you can also replicate it to multiple nodes if you want to have the same use case across multiple locations. Let's say you have 3 machines of the same type and you want to apply the same use case on all of them. Then you can just select them here and then press deploy. And then this flow will be installed into those nodes. And from there on, they will run in those local environments independent of this control center tool. So they will continue to run in those local environments until you decide to remove them or maybe update them with an enhanced version of this flow with additional features or whatever you want to do. So that's the basic workflow to bring these models into an edge environment. Then a typical use case or scenario when you have this type of use case, as David mentioned, is that you may want to update the model because you have made improvements to the model, or it covers different use cases, or maybe other changes that you have made. So you want to use another model file. And if you want to do that, you don't really need to change this flow that you have running. These flows are parameterized or parameterizable, I should say. So we can make this model file that we use here just a parameter which you can change so that it points to another model file. So if we get the new version of the model from Databricks, you can bring it in and then just change that reference, and then you can restart the flow with a new model file without having to touch this design here. Otherwise, everything is version control, so you can also create a new version of the whole flow if you want. But if you just want to change the model, then you don't need to do that. You can just reference another model file and use the same flow again with that model file. So I'll stop there. There are more tools. I mean, once you've deployed it, you of course you also want to make sure that it's running as you expect. So there's also a monitoring part of this tool that you can use to track the flows that you have and so forth. But we don't really have time for that in this short session. But just get back to us if you want to get more input on how to do these kind of things. So I'll stop there and hand over to you again, David.
Excellent. All right. So with that, we'll open up to the audience here for any questions. I think that was an excellent presentation from the Crosshair team here and Göran. So, Göran, any other final words on getting in contact with Crosshair to help bring this to life on the edge side?
Yeah, I mean, there are multiple ways. You can always reach out, of course, through email or our website. We also have free trials that you can sign up for if you want to play around yourself. There's free online training that can help you get started. And we also run dedicated demos of the Crosser solution every Wednesday. So actually in 15 minutes, there will be a live demo of our solution where you can get more information.
Excellent. And likewise, on the Databricks side, there's ways you can if you're not using Databricks today, there's Databricks community you can get started quickly with. You should have Databricks within your enterprise. Our account teams will reach out to you if you're interested in moving forward. So all of these things are available to you. We have a lot of materials that help walk you through this architecture center. There's a blog post jointly Crosser and Databricks put out back in April from Göran, myself, and Zach. So there's lots of ways to help you kind of find success here in deploying this type of workflow. And thank you for your time. I really appreciate your attendance here and really looking forward to working with you all help deploy your industrial AI workflows.